Hello everyone, this is Teampo's presentation for the design competition. As we know, in the design competition, the task was to create a system for flood and rescue missions. So we have designed a set of three devices for the rescue missions. So the first one is a drone, which is used for aerial surveillance, and the second one is a device which I have named as water surfer, which is used in flooded areas, and the third one is for the land areas. It's like an off-terrain vehicle with an excavator arm on top of it. Now I will explain each of these devices in detail. The first device we have is a standard drone on which a gimbal camera is attached. The drone here performs the activity of aerially surveilling an area and searches for the people who are in need of rescuing. It is manufactured from plastic materials and could be 3D printed as well from materials like ABS. And here, the use of gimbal camera helps in generating steady images so that one could gain accurate information of people who are in need of rescue. And this information, which is gained from the from viewing the images, is shared with other operators so that other devices could work in coordination by the information obtained. For the second device, let me explain it using a scenario from the recent floods in which some people were stuck on the roof of a house. In such a situation, an operator throws this device, water surfer, onto the water, which is then remotely operated by him, and he sends this here or sends this device towards the people so that the people can hang onto this device while the operators bring them back to the land area. This is the second device, which is an aquatic rescue device. It has a compact and a stable platform. Basically, these three chambers are chambers that are filled with air or some other buoyant materials that helps it stay afloat in the water. And these chambers also contain the storage for electronics or batteries, which can be stored there. And the light, and it is equipped with lights, so it can be used in places with low visibility or in night time. And we have used a set of BLDC motors which is equipped with propellers so that it allows for traversal in water areas. So as I explained previously, this device is thrown onto the water surface, and it reaches the people who are stranded in the middle of river or in some scenarios, and they can hang on to these area areas. So these are basically yeah, places created for people to hold and so that the operator can bring them successfully back to the shore or the land area. So this is the third device for search and rescue missions in land areas. It is basically a six-wheeled vehicle which has an excavator on top of it with grapple attachments. It is equipped with PTZ cameras. So the PTZ cameras have this characteristics of being highly resistant, and they have built-in IR LEDs, and they offer night vision as well. Uh, since I've included this type of camera, so I've not added any headlights to this vehicle as it offers night vision, and the steady images from the camera can be used for assessing the situation. And so and basically an operator near the device uses uses the excavator to perform the search and rescue missions. It could be used in scenarios where the road is blocked due to fallen trees or logs, and logs due to landslides. So this is basically the base of the previously shown vehicle. This uh, this vehicle is driven by a single power source, and a skid steer mechanism is used for steering. So it is different from the conventional known method of steering in let me explain the skid steer mechanism with a figure. In modern day everyday vehicles, a modified version of Ackermann or anti-Ackermann steering geometry is used, in which the front wheels are turned at some angles at respect to each other, in which the rear tires have no steering at all. So this is a figure of an explicit steering configuration with rear steering as well. And the steering we have used in our device is a skid steering configuration, in which the tires run at different speeds. So this skid steering configuration is similar to the differential drive robots, in which the tires also run at different speeds for steering. But there is a subtle difference between skid steering and differential steering. In the differential steering, each of the tires are run independently, but in skid steering, all the wheels are mechanically linked, so they run at same speed. And by reducing the speed at either side of the vehicle, the steering is done in skid steering configuration.